Welcome back, everybody. We're continuing Chapter 3 on vectors. And in the last section, we talked about how to take the components of a vector and resolve it into the actual vector itself, and also to determine the direction and the quadrant that that vector is in. Now what we're going to do is we're going to be adding vectors themselves together. So you can have two different vectors at two different angles. We're going to add them two different ways. The first way is going to be kind of the long way, and then I'll show you kind of a shorter way to do it, but at least the long way will help you visualize it a little bit more easily. So I think it's worth doing the long way, that what we call the graphical method, and then the shorter way called the component method. I think you'll be able to visualize it, but it'll also be shorter as well. So let's go ahead and get started. The idea here is that if we're going to add vectors together, we add we put the tail of one vector on the head of the other. For example, let's say if I have vector A, it's at some magnitude and at some angle, plus vector B. What does that look like graphically? Well, say here's my origin right here. Okay, we'll say that vector A is going to be, and in fact, I'm going to see if I can erase. Oh, I'll make vector A red. All right. Vector A is going to be red. Vector B is going to be blue, and so A we'll say is I don't know, 5 meters at 20 degrees north of east, and vector B, I'm just going to make this up, is 3 meters at 10 degrees south of east, like that. Okay? This is what it looks like. We draw vector A from the origin. So it's going to be 5 meters at 20 degrees north of east, so it's going to look something maybe kind of like that. All right? That's vector A. And so to add B to it, we start B at the tip of vector A. So it's almost like we're creating a new origin. All right? Like vector B is originating from where vector A ended. The vector B has got a downward angle, and it's a little bit shorter. So it'll be something kind of like that. Vector B. All right, so we add them, we say tip to tail. So we put the tail of the one on the tip of the previous one right there. And so what that means is that creates a sum vector, like SUM vector. The idea is that vector A plus vector B equals some resultant vector. In this case, we would call it vector C right there. So I'll draw that in purple. All right, vector C. So what would vector C look like? Vector C would be from the original origin to the end of the final vector. Vector C like that. All right, so A is going forward, B is going forward from the tip of A, and C says, all right, let's do what A and B did all in one shot, and represent that as one vector. So C literally is the representation of the sum of vector A and vector B. All right, so let's go ahead and apply that in example 3-4. Okay, so I just had to pause that for a second, and now I'm resuming it. So this is several minutes later after the last sentence that I just said right there. So if I recall correctly, we're talking about adding vectors together and doing it graphically. And so now we're actually going to start up with that. So we have two vectors that we're going to add together. Those vectors are vector A right here and vector B. Oh, and there's a bell. I am doing this during school in one of my free periods. Vector A and vector B, like so. So we're going to add them together graphically. Now, in order for you to do this, you would need a protractor. Now, not necessarily does everybody have a protractor at home, but I'm going to just sort of demonstrate to you the way that we would do it using a protractor, and then we can practice that more in class. Ultimately, this method is really just to help us visualize what it looks like to add vectors together. We're, like I said, ultimately going to actually develop a more elegant way of doing this anyway. So, as a quick sort of example of what happens if we add vector A and vector B, first of all, I'm going to make vector A red. All right, so this is vector A right here. I should have an arrow over the A. And vector B is going to be blue. I'm going to do that, and it has those properties right there. So, vector A. We tend to add vector A first because A just comes before B in the alphabet, but really you can add them in any order you want. But I'm going to add vector A first. So we're going to start from the origin, and we're going to have a 5.0 meter, well, I can't draw meters, I'm going to probably draw centimeters, or really whatever units you want to right here. This vector is going to represent those 5.0 meters. All right, so we'd use a ruler and a protractor, and to draw that vector, that's probably not steep enough. I'm going to make it a little bit steeper. How about like that right there? All right, 5.0 meters. That's vector A. It's 5.0 meters. You would draw that length, and actually probably what you would do first is you would measure out the angle with the protractor. So you would probably put a mark that is 60 degrees above the x-axis. You'd probably put a mark there, like so, and then you would draw your line to the right length and have your vector end right there. So when we add vector B to that, so vector A being the right length and then at the right angle right there, to add vector B to that, what we do is we kind of start vector B at the tip of where vector A ended. So we're going to see that vector B is going to be slightly shorter, and it's going to be a little bit more shallow angle right there. So pretend that we're starting at a whole new origin right there where vector A ended, because here's where vector B is going to start. All right, so it's going to be 4 meters long, or 4 units, whatever you want your unit to be, at 20 degrees above the positive x-axis. Well, it's going to be in the same general direction, but now it's going to be a shallow angle above the axis. And remember that we're starting right here, so this is going to be our new x-axis that B is originating from. Okay, so let's see if I can sort of do this. I'm not really using a ruler either, or protractor. All right, so if we can sort of picture this x-axis extending out kind of like that, the idea is that this new vector is going to be 20 degrees above it, like so. So that's our 20 degrees. And the length of it is the correct length. So you would probably measure your 20 degrees here and then put a mark right where the 20 degrees on the protractor sits. And then you would draw your vector to the correct length. In this case, the vector would be, vector B would be 4.0 meters, 4.0 meters at that 20 degrees above the positive x-axis. All right, so both vector A and vector B are in the same general direction, kind of in the north of east direction right here, and they're added together. They're added together because vector B is kind of put right at the end of where vector A ends. So to represent vector C, which vector C I think is logical that I would make that purple or violet, vector C represents the sum of them. The sum of vector A and B together. So vector C does what vector A and vector B do together. So vector C would simply be this. Like so. All right, and so to find the value of vector C, you would need with your ruler to measure this length right here. I don't even know what length that is because I don't have a ruler because this is on my, my iPad right here. So you would measure that with your ruler. In fact, let's just draw in kind of a ruler like that. Okay, so that's, you would measure how many centimeters that would be. And then to measure the angle, you would measure it, that angle from the positive x-axis. We always measure the angle theta from the x-axis. Not from the y-axis, but from the x. And so you would measure the length with your ruler, and you would measure the angle with your protractor. That's how we would find the magnitude and direction of vector C. So that we would state vector C would be, this would be our final answer, it would be x number of meters. What does that look like? I say this is 5, and this is 4, I don't know, you want to say 9 maybe, something like that, or maybe 10. All right, 10 meters at some angle. What angle does this look like? I don't know, maybe 45 degrees, okay? 45 degrees, you could say north of east, or we could say above the positive x-axis. Either one of those is legitimate, okay? And that would be our answer for vector C right here. But it does require a ruler, and it does require a protractor, and it's a little bit labor intensive. And the other thing is that there's probably going to be some degree of error involved. So while this is a legitimate way of measuring a resultant vector, that is C being the result of A and B added together, it is a little bit error prone, and it is somewhat labor intensive. So I'm going to suggest in just a second, probably actually in the next video, a way of doing this that is a little bit more elegant that we're going to call the component method. Real quickly before I do, I just want to talk about what happens if we subtract vectors. All right, well, just a minute ago we had vector A, let's see, right here, so vector A was like that, vector B was added to it, like kind of like so, and vector C was the sum of those vectors, so going from the original origin, that was vector C. But what if we have vector A minus vector B? A minus B right there. I didn't do them with the right colors. Oh, you know what? I'm sorry. This should be B. My bad. I'm just going to write in red for the time being. A minus B, what does that look like? Can you have a negative magnitude? No, you can't. But you can think of it as being in the opposite direction. So think of it kind of like this. A, instead of A minus B, A plus negative B. And so what this is going to produce is going to be a very different vector from the sum of them. We know that 5 plus 4 equals something, and 5 minus 4 is going to give you something completely different. So what does this look like if we were to subtract vectors graphically? Well, we still have vector A right here, right, original vector A. But when you subtract a vector, you have vector A or vector B right here. You can't have a negative magnitude, but you can have a negative direction. So taking vector B right here, negative vector B, is simply like taking it and drawing it on the tip of vector A in the opposite direction that it normally would go. Here's regular vector B right here. Here is negative B. Same magnitude, but the opposite direction. So if this is 10 degrees above the positive x-axis, this would be 10 degrees below the negative x-axis, right there. And so our vector D would be very different from our vector C. It would simply be from the original origin to where the final vector stops. So we simply just kind of add the negative of the original vector, and that's how we subtract vectors graphically like that. We're actually going to use that when we do it using the component method as well. Just think of that vector as being in the opposite direction. You can't have a negative magnitude, but you can have a negative direction. All right, that's going to be it for graphical vector addition. In the next video, we're going to talk about the component method, which I think is it's a little bit more tedious, but it's going to give you a lot better results. And I think once you get good at it, it's going to come a lot more quickly to you. Okay, so that's it for now. Thanks for following along. I'll see you on the next one.